We're going to talk about the discriminant. The discriminant is something that is part of our quadratic formula, and it's used not to give us our actual solutions, but only to tell us how many solutions we have. Okay, the discriminant is based on part of our quadratic formula, but think back to your quadratic equations. Sometimes when you graphed a quadratic equation, you saw that there were two x-intercepts, which meant you had two solutions. Sometimes there was only one x-intercept, which meant there was only one solution, and sometimes there were no x-intercepts, which meant there were no solutions. So the number of solutions is based on what the graph looks like. And you can find the exact solutions using your quadratic formula, but if all you care about is how many solutions you have, you can use something called the discriminant. Now, the rule is if you have two x-intercepts, that's two solutions. That means you're going to have a positive discriminant, and I'll explain why in a little bit. I just want to give you kind of the foundation here. One x-intercept, one solution will mean you have a discriminant of 0, and no solutions means you're going to have a negative discriminant. And again, I'll explain the logic behind these three things once we start actually solving problems. So what is the discriminant? The discriminant is a formula that is part of our quadratic equation, or part of our quadratic formula, and specifically it's the part that's underneath this square root symbol. Okay? Now when we're finding the value of our discriminant, we don't actually take the square root, we just look at the b squared minus 4ac. But I want you to know that it's the part under the square root symbol, because that'll be important in understanding how we know how many solutions we have. So let me show you how we do this. Just like our quadratic formula, we need to have equations in standard form that equal 0, and we need to find out what our a, b, and c values are. Once we know that, we're just going to plug into this formula we have, b squared minus 4ac. So in this case, b is 3, so I'm going to have 3 squared minus 4 times a, which is 1, times c, which is negative 4. So then, just order of operations, 3 squared is 9, negative 4 times 1 times negative 4 is positive 16, and this gives me a discriminant value of 25. Now 25 is a positive number. Think for a minute. This is the part of our problem that's under our square root symbol. So essentially my next step would be to take the square root of 25. Anytime we have a positive number that we take the square root of, we know we get two answers. The square root of 25 is equal to either positive or negative 5. So that means if we have a positive discriminant, that means positive discriminants are going to have two solutions. One would be the positive root, the other would be the negative root. Look at this problem here. Again, it's already in standard form, already equals 0, so I know my a, b, and c values. So I'm going to plug into my formula here. Okay. Now, b squared is going to be negative 12 squared minus 4 times a, which is 4, times c, which is 9. Well, negative 12 squared, negative 12 times negative 12 is positive 144, and negative 4 times positive 9 gives me negative 144. So 144 minus 144 gives me a discriminant of 0. Now, discriminant of 0, again, let me explain what this means. That means my next step, if I were using the quadratic formula, would be to take the square root of 0. When you take the square root of 0, you only have one answer, 0. So any time you have a discriminant value of 0, it means you have one solution, because the only square root of 0 is 0. Now for this last problem, I showed it a little differently. Look, it's not equal to 0. So my first step here is going to be to add 9 to both sides to make this equal 0. So I've got x squared minus 5x plus 9 equals 0. Now I'm ready to figure out what a, b, and c are. And then from there, I can use my formula. So my b value is negative 5, so I'm going to have negative 5 squared minus 4 times a, which is 1, times c, which is 9. So negative 5 squared, negative 5 times negative 5 is 25. Negative 4 times 1 times 9 is negative 36, which gives me a discriminant value of negative 11. So again, thinking back, square root of negative 11, can I find the square root of a negative number? No, it's impossible. And since it's impossible, we can't take a square root of a negative number. What that means is anytime our discriminant is a negative number, we have no solutions. And that's how the discriminant can help us figure out how many solutions we have to a quadratic equation.